everyone. This problem has been asked in GATE 2023 and the problem is from the signal and system subject. So the question is that a signal xt is equal to 2 cos 180 pi t cos 60 pi t is sampled at 200 Hz and then it is passed through an ideal low pass filter having cutoff frequency is given as 100 Hz. The maximum frequency present in the filtered signal in Hertz will be, and the answer should be round up to the nearest integer. So if you want to go to the detailed description about this about the basics of this problem, then you can refer this NPTEL course Fourier transform of sampled signal. This course is given by this Dr. Kushal Shah, Department of EE and Computer Science, IISER Bhopal, and the link for this course is given here. Now, before we begin to solve this problem, let us have a quick recap on this basics of the signal sampling theorem and the output of sampler. As we all know that signal sampling theorem states that a continuous time signal can be represented in its sample and can be recovered back when sampling frequency fs is greater than or equal to twice of the highest frequency component of the message signal, that is fs should be greater than or equal to 2 fm. So we have to not in this question it is not asked about the sampling theorem, but the basics of the sampler we will see through this picture. So here the sampling of input signal xt can be obtained by multiplying xt with an impulse train delta t of period ts. So this is very important how we are getting this the output of sampler. We have to multiply this input signal with an impulse train delta t of period ts. So sampling of input signal, how is it is going to done? We are multiplying the impulse train with the input signal of period ts. So the output of multiplier is a discrete signal called sampled signal which is represented with by t. So here all the pictures have been given. Xt is this input signal, delta is the impulse train, and both gets multiplied, we get the output as like this. Now if we take this Fourier transform of this sampled signal, then we get this equation. So here the output of sampler is very important. What are the frequency components is present at the output? So we can see that the frequency components present at the output is f minus n omega, f minus nfs. Here it is written as omega minus omega n omega. So you can also write f minus nfs, and in better way you can represent like f plus minus f nfs, because n is varying from minus infinity to plus infinity. So this is the requirement. Now this is the block diagram for the problem. So we are having this input signal xt and it is going through the sampler whose sampling frequency is 200 Hz. Now this output signal is passed through low pass filter whose cutoff frequency is given as 100 Hz, and we get the output, and in the output we have to find the maximum frequency component present at the output of low pass filter. So we are given with the input signal as 2 cos 180 pi t into cos 60 pi t. Therefore we will get xt as cos 240 pi t plus cos 120 pi t. How we are going to get this? This is coming through this relation 2 cos a cos b. We can write it as cos a plus b plus cos a minus b. So on putting this using this expression, you are getting this getting this expression, and from here we can get the frequency components, that is 120 Hz and 60 Hz for the input signal. Now we will get the frequency components present at the sampler. Output will be, this will be NFS plus minus 1, and another output will be NFS plus minus 2. So on writing this like F1 Fs plus minus 1 to Fs plus minus 1, that you will get 120 Hz, 200 plus 120 Hz. Now we are not calculating more than this because this cutoff frequency of low pass filter is 100 Hz. So if you go beyond this 200 plus minus 120 Hz, anyway the frequency components will be more than 100 Hz. So we are not taking that part. Therefore, this frequency components at frequency present, the signals having frequency component present at this sampler output will be 120 Hz, 80 Hz, 320 Hz. Now for the other part, the frequency will be present like F2 Fs plus minus F2 2 Fs plus minus F2. We will get 60 Hz, 200 plus minus 60 Hz. Similar way here we have not taken 2 Fs plus minus F2 because these signals will be anyhow greater than cutoff frequency of low pass filter. Therefore this 60 Hz, 140 Hz, 260 Hz frequencies are present at the sampler output. The signals having frequencies 60 Hz, 140 Hz, 260 Hz, and so on will be present at the sampler output. Now it is given that cutoff frequency of low pass filter is 100 Hz. So it will pass only 60 Hz and 80 Hz 80 Hz frequency components, and this will be get rejected because the signals having frequency 120 Hz, it will not pass through the filter. This will also not pass through filter. This will get passed. This will also get passed. This will not get passed. This will not get passed. Therefore, the final answer for the problem is 80 Hz because it is asked about the maximum frequency component present at the filter output. Therefore, final answer is 80 Hz. That's all. Thank you.